All right, I'm talking about componentizing end-to-end tests. So this is my first time being at a conference speaking, so I'm going to start with, thank you. So I'm going to start with some icebreaker questions that make me feel better. So who here has written web applications? Looks like quite a bit. All right, who's written unit tests? Yeah. All right, so who writes end-to-end tests using Cypress, Test Cafe, Selenium, WebDriver, et cetera? Okay, less people. All right, so who thinks that they're easy to write, debug, or maintain? Not very many hands. Okay, cool. So this talk will help. All right, so I'm going to put a statement out there that writing end-to-end tests is hard. So one thing is figuring out how to select something. There's all kinds of different things. Do you even control what they are going to be? Race conditions, both in your applications and also maybe in your test runner. Data can be hard to control. And also, UI changes tend to break tests. I know that for the last 5 years at a company, we had offshore doing our end-to-end tests for us, and they had an entire team just trying to keep those tests running because obviously the UI was changing constantly, and so the tests were constantly breaking. So now that I've postulated all that, I'm Nicholas Boll. I'm a design system engineer at Workday. Design system engineer is kind of what it sounds like. I am an engineer on the design system at Workday. The design system is called Canvas. It's open source in July. So how do we break down our applications? Because we have to build complex applications. So how do we do it? So this is just a screenshot that I took from Sencha's website. They have it's like a kitchen sink example of just a complex application that's just like a dashboard, some menu items and stuff. So when you look at this, we probably try and visualize how we would break this all down. And we'll probably draw boxes around that, like layup boxes. We might even call these components. And obviously, this application has multiple widgets. Those widgets have titles. We can start to see some common themes. I added some color coding, so like the menu has menu items, and I've outlined that with purple. And widgets I've kind of outlined with red, and then their titles I outlined with yellow. So we can kind of see these patterns of repeating pieces that repeat over and over and over again. And this big problem was broken down into small pieces and then kind of built up to make this complex dashboard application. So how would we target that email icon? So maybe we wanted to click on it. So that one right there. So we might choose the first option I had, which was a selector. This is an option. This is called XPath. Hopefully you don't use that. It's very fragile. You can see the numbers in brackets like 3. That's the third div under the body, and then there was a second div under that one, and the first div under that one, and then the anchor tag. You could maybe use the class name. That seems a little bit more stable, maybe. That was a problem that we had with our offshore team. They tried to figure out what selector would be best. Obviously, XPath changed too often, so they tried class names. But if we go to things like CSS and JS, those class names are changing constantly. So another option might be like a data test ID. That is something that we could control, and it made it a little bit more obvious that that was something specifically for testing so that developers didn't accidentally change that too often. But then the next question is, where do these selectors go? Where do you put them? So one option is co-located with your source code. That seems like a pretty obvious choice. I've got the import React statement at the top, and then I'm just going to go ahead and export a const called selector, and I'll just name it data test ID email. So now you can just grab that selector, and now you can grab that icon. You can see that's matched to the icon's data test ID inside that email icon component. So some pros and cons. So it's very easy at the unit testing level. It's nice and co-located. It's easy to tell where it is. It could be bad for end-to-end testing. So I don't work for Cypress, but I've contributed there, and so they gave me a nice T-shirt. So if you did this in a Cypress test, the way they do that is every test becomes its own small application that it wraps up into, it injects itself into your application's page. So what ends up happening is instead of just grabbing all of your test code, it also is now grabbing the whole of React. So that can be bad. It will slow down your tests because it has to compile and parse and all that, the entire application, not just test code. So the next thing that we tried doing was doing a global selectors file where we just listed out and tried to add names to all the selectors. Now this is a nice list because everything has test IDs, but we had complicated CSS selectors before. It was a little bit more obvious. What was nice is this was in our source code so that we could at least see what it was, where before it was in a different repository, in a different technology that we didn't have secure access to, so we couldn't even see what selectors the offshore team chose. So this was at least a little bit better. We could import them all, and then at the bottom, we just said, this is all my examples are in Cypress, but this could work for any testing framework. So we just got this. We just called this i.get, which you just give it a CSS selector, and then we could go on with that. So there's some pros and cons of that. It's easy to tell where everything is at once, but it's not modular. If you've done some Redux stuff and you have all your actions in one place, that works out pretty well until you get to a certain scale, and then that file is just huge. And you accidentally add selectors multiple times because the list is just too long. So you could have local selector files. So that's what we ended up moving to next. So we had each area had its own kind of selector thing. So all the icons had a selector, and then all of the maybe cards had a selector, and then just in our index file we just re-exported everything. So now we could just do namespacing. So now I have a sci.get selectors.icons.email. Is a little bit cleaner. So it was more modular. But then we quickly ran into an issue where our selector is powerful enough. We have complex applications, so we have more and more complex interactions to do something that we want to do. It's pretty easy to describe in English, but it was harder to do in our implementation, especially if it had to be repeated. So how do you target an item on this to-do and then check it off? So I'm talking about this one down here. So that first one, you might do maybe you'd say that could be that XPath, or maybe you would get all of the to-do items and then pick the first one. But maybe we want to just grab it by something that we can see within the application. So we might want to grab it by that name. Now, some of you might be alluding to the next part. Could we just use, oops, sorry, that took a little bit. This was too complicated for our selector, so we had to look for something else. So I said before, all our examples are in Cypress, but it could work for any framework. So some of you have heard of React Testing Library. So originally that started as React Testing Library, and then it was kind of abstracted into Testing Library that added adapters for a bunch of different things, including React View, Cypress, Puppeteer, and Test Cafe. So I remember first hearing about that for Cypress. So they even have one helper for React Select, and that was surprising to me because we were doing that, I think, before Testing Library added it, but it's on listed as one of their adapters. So I thought that was pretty cool because it was kind of along that same idea. So this is if you are using the to-do using the testing library with the Cypress adapter, you would use query by text and just say upgrade to SSD hard disks, and then you would click on it. And then hopefully it doesn't actually work with how Sencha implements their application, but let's pretend that it does. So that's cool if you have the selectors that would work well for how the React testing library does, which is around text, and it also has nice helpers around forms. But what if your stuff is a little bit more specific, like the Sencha application, where it doesn't quite work like a modern application would, the DOM would work. So you need something a little bit more custom to get the right thing. So I coined it as component helpers, or basically component helper functions or helper functions. We had a few different names for it. So they look kind of like this. So the first thing I did is just created a function called getToDoByName. You pass in the name, and what it does is it returns you a Cypress chainable object by some selector. Now, the only place that that selector is available is inside of the helper itself, so your test code doesn't actually deal with it at all. The next one is just getting a checkbox, so given that to-do item, we want to find the checkbox within it. And then the last one is just we want to check that to-do item, and you can see I'm starting to compose some of those helpers within the same file together. So a check to-do item is now getting that item by its name. It's then getting the checkbox out of it, and then it's clicking on it. So it kind of looks like this. We wanted to first check that to-do item, and then we wanted to grab it, and then get the checkbox, and then do an assertion on it, and make sure that it's checked. Now you notice there's no selectors in it. It's kind of like the whole thing around page objects, where you're not dealing with the underlying driver directly. You're kind of working at a little bit higher level of abstraction. And then it becomes a little bit more, it's not exactly English, it's not like Cucumber, but it's a little bit, it's fairly easy to read and understand what's going to happen. This worked well for our PMs and our QA to be able to have some confidence that we were doing the testing that we wanted to do and that we said we were doing. So, other components, obviously like a button probably doesn't need much for helpers because all you can really do is click on it and maybe assert on its text. But there could be other things. So components with portaled content. Now, portal is kind of something that was coined by React. I think in Angular before they call it transclusion. But it's basically taking content and projecting it to another place within your component tree. So like a modal. If you can imagine, a modal is like a picture frame, and you want to take the picture and shove it into this frame. And the modal component is the frame, and your content is whatever you want to put in that frame. So that's what I'd describe as portal content, something that moves somewhere else. Portal specifically is actually going to be something different in the DOM, so it's not going to be a direct child. It's going to be related maybe through an ARIA owns tag, but it's going to be basically put at the bottom of the DOM so that it's not confined by the overflow of the container of the target. So modals will do that so that it's not clipped by whatever that target is contained in. So that can be tricky because you can't just find it. You can't just take the target and then just do a .find, because now it's going to be scoped to the document instead of to that component. So hierarchical menus, if we have multiple layers of a menu, you have to click on it to open it, then you have to find your item, and then you have to click on it, and then it opens up another submenu, and then you want to click on it. That can be more complex, where you just want to describe the hierarchy of it to select what you want. Another one might be combo boxes. We might have some complicated things around how you'd select things, especially if there's some virtualization going on. Cards, you might want to just say, I want a card of some domain type. Like, I worked in a cybersecurity company, so we had things like alarm cards and case cards. So we wanted to just select that card by its name, but we wanted to get the card and not the text. So we could just have a component that would grab the card by whatever the name contained or ID, and then return that card and do other actions on it, like change the status. Dashboard widgets, similar to the example that I had. And the biggest one at the company I worked with was virtual lists. We had virtual lists for everything, which definitely made testing things harder because we couldn't just grab something in the DOM and then click on it because it didn't exist in the DOM. It was virtual. So now I've got a demo of how I've done that using React Select Virtualize. I don't know if anyone's used that before. So this is kind of what it looks like. This is with 8,000 items in it, so as I'm scrolling, it will actually keep going. It's opening and closing pretty instantly because it's only rendering exactly what you see. It's using React Virtualized under the hood. And it will just go on, and you can scroll quickly and get to everything. So I've got a simple spec here that just grabs it. So this is without any component helpers. This is just, we are going to grab it. We have to know what the selector is going to be. We have to know what the next thing is going to be, which in this case, I want to open it. I want to find something that contains the number 5, and then I want to click on it. And now I'm going to make an assertion that it still contains that 5. So I have selectors in here. I have to know the implementation details of how this thing works. So I've got this first test, and this is what it looks like. It should just work. It looks fine. So why would I need any helper for this? Well, if the item I happen to want to be selecting is not on the first viewable page right now, that's an implementation detail for how the component works. So let's say I wanted to select the item number 100. So we'll just change this right here to 100. Now this should reload, and it's going to sit here and wait, and it will eventually fail because it can't actually click on an option that has the string 100 on it because it's down there. Now, interestingly enough, if I refresh this and manually scroll it down to the item of 100, it will pass. So to most people implementing it, that just happens to be an implementation detail. It's not something that I necessarily care about. All I really want to do is select a very specific option within this list. The fact that it's virtualized, I shouldn't really have to care about. It could be not virtualized at one point, virtualized later, and I shouldn't really have to care about that difference. But it went through and it did everything that you would expect. It grabbed this item by this selection. It went ahead and clicked on it. Then it found an item that contained 100, it clicked on it, and then it ran an expectation against that to make sure that it contained this -100 on there. So I just looked at the implementation of React Select Virtualize. I've never actually used it before. So I just made those helpers. So I just made some way of getting the component so that you can just call it. You just import this function, and then you just call it. Then the select was a little interesting. So what I ended up doing was I first grab that element and I click on it just to open it. Then I end up getting this selector here, which normally you never have to think about. But this is the overflow container that contains all the virtualization. So what I'm doing is I'm scrolling that. So I'm sending a scroll event. I'm telling that container to scroll a little bit, and then I do an assertion on it to see if the item that I wanted is there, and if it's not, then I'll keep scrolling. And I'm tying it to request animation frame to make sure that React fully flushes to the DOM before that's done. So here's the implementation of scroll to. So this component opens it, or this helper opens it, it grabs that container, it tells it to scroll to, and it gives it a nice long timeout so that it doesn't, the default is 4 seconds, and it might take us longer, so I just set that to about 10 seconds. And then once I found it, then I'm going to go ahead and click on it. So what the scroll to does is it's an async function. It takes in a match and returns an async function that is then takes in that element. And it will continuously look for to see if there's any node in this node list that contains that string that you gave it. And if it doesn't, if the length is 0, it will go ahead, await a request animation frame cycle to make sure that the DOM has been properly flushed. It will set the scroll top to be +20. This is just for demo purposes. I actually made it in production go a lot faster so that it's going to scroll about 1 page at a time. But it's hard to see what's going on. So after that, then it just calls the scroll top, sets it to the new scroll top position, and then when it's done, it will return that element so that it can be clicked on it later. So what that ends up looking like, so the same thing, I'm going to select that same item number 100. And now I'm using my nicer API, so I'm just calling a get select, which is returning Cypress chainable objects. I'm using pipe, so if people have used Cypress before, pipe is actually a plugin that I've made. It's similar to .then. It just does a little bit nicer outputting, which I'll show in a bit. And then I just pipe in that select function that I imported. And then I just give it what string I want it to match. And then later I get that same select, and I'm just doing an assertion of that containing this text string. So now this is what it ends up looking like. It's going to scroll through automatically on its own and find the right item. So now I don't actually care if it's virtualized or not, if it happens to be viewable or not. It'll just run through. Now, when I talked about pipe, this is what pipe gives me. It gives me a nice little item here. It tells me what function was called, as well as a before and after of that call. So if you use a .then, it doesn't actually show you any nice things in the log here. So I'll slow that down a little bit, and we'll watch that. It's kind of fun to watch when it's running. So we'll just slow it down to maybe like 8 pixels at a time. So you can see it's scrolling a lot slower, but it's the same basic concept. And then once it finds the item, it'll either time out because it can't find it, or it will scroll enough that it finds it, it'll select it, and then it will move on. All right, so component helpers help us abstract our implementation details. Just like components are a contract for developing our UI, component helpers are a contract for testing our UI. So we ended up proving this over the course of 2 years, but the implementation can be changed without our test breaking, as long as those API contracts were the same for our component helpers. As long as our implementation, our component helpers were updated with the implementation, nothing ended up breaking. How we ended up doing it is our component library was pushed into our local NPM repository. Our helpers were also pushed to that same repository under like a /helpers. So our CI was tied to testing out our helpers of our components. So we could guarantee that as long as our APIs did not change, the application test would not break. If they did, our CI would catch it before it ever got to that point. So what ended up happening was all of our application failures were because the application was breaking. Some specification of the application changed, not because the components changed. So component helpers can be composed. So we ended up proving this out for, we had multiple component libraries, and the leaf node, the lowest level one of our design system, it had these component helpers for the very, very basic low-level components. And then those were consumed by higher-level component libraries, and those were consumed by widget repositories. And then eventually it was consumed by the application. So each level created their own helper abstraction layer, and it kind of built on top of it. So when we had more within our dashboard example, we had some of those widgets or those apps. They had some complex interactions, and we just had easier ways of dealing with them. Like one of them was like an identity list, and it was using this idea where it would scroll through identities and searching for if it expected there to be an identity, anomalous identity risk above some certain level. It made it a lot easier to just give it some risk that we wanted it to test against, and then grab it and then move on. So here's some of the links that I had. First one's design.workday.com. That's Workday's design system. There's the React DOM testing library. Here I have a link to the Sencha dashboard example that I had, and then cypress.io. There's no timer up here, so I have no idea where I'm at. All right, and this talk is supposed to end at... I'm actually done. I hope I didn't leave too much time left.